has joined by telephone, just let me know that you're here. I have Randy and Cheryl so far.
Are you on mute or can I hear you?
I don't think I'm on mute.
No, you're not on mute. We can hear you. Let her know on mute. It was Tremaine.
Okay. Okay, thank you, Randy. It looks like we have some other people who have joined by their computer. So we will take note of those attendees. And I have several that I don't have a name on, so I'm not sure what to do about those.
In order for them to log on, their name will pop up.
Okay.
They're just waiting. They're waiting. It's running in the background.
Okay, so Karen, our trustee assistant, is here helping us sort some of these things out.
So I wouldn't worry about that.
Okay.
They're running in the background.
All right, so we're just going to get started. It's a few minutes after 1. Just very quickly, welcome to today's session of the ASHRAE 2016 training. Thank you all very much for joining us. A quick run through of the agenda. We're dealing with taking attendance.
Come get me if you need.
We'll show you the training objectives. We'll go through the presentation. And just want to let everyone know that this webinar will be recorded and posted on the MaineHousing website. And we will send you a follow-up email and show you where the link for all of that is. Oh, someone else has welcome, whoever just came online. I want everybody to know that Rick Karg is now attending as a listener. He's on the line with us, and he is going to join us live for his segment of the presentation. Wanted everybody to know that he's joining us today, and we are thankful to him for helping us with this training. So if you would please keep your phones on mute so that we don't have feedback and chatter. Certainly if you have questions, please type them into the chat screen, and we will keep track of them. Any that we can answer quickly and easily, we will answer through the chat screen. Any that we feel we need to save for Rick or we feel they might be answered later, we will handle those questions at a different time. But please feel free to go ahead and type any questions that you have into the chat space. So our objectives today are to let everybody know that there is a DOE requirement to use ASHRAE 62.2/2016 in the Weatherization Assistance Program. That's guidance from the Department of Energy. We are going to clarify the differences between the 2013 and the 2016 ASHRAE standards. There really isn't a lot of difference except when it comes to small multifamily buildings, and we will go over that. We want to demonstrate the practical application of the standard using demonstration videos of the Residential Energy Dynamics tool, which Rick Karg is going to walk through with us. And also, we want to provide an opportunity to have live Q&A with Rick Karg so that he can show us some other items that are more relevant to Maine, aside from the tutorial video that we'll watch. And you'll have a chance to have some live question and answer period with him. And Al and I, at the very end, will also give some guidance about how to document the ASHRAE items in the Hancock software. And again, we'll make a recording of the training, which we're doing right now, and that will be available for everybody. So the guidance on this came down from Department of Energy. There is no actual written guidance on this at the moment, but we certainly have heard it on several phone calls from Josh Olson, who's the policy T&TA advisor at DOE, that we are to use the ASHRAE 62.2/2016 version for fiscal year 2017. So we did include that into our state plan. And given that we are providing this training somewhat after the beginning of our fiscal year for 2017. We are going to have that come in effect for any audits starting August 1st, 2017. So after this training, everyone should be conversant, and we'll expect to see 2016 version of the standard being used in your audits. Don't see any questions in the chat so far. So I'm going to play a very short tutorial video from the Residential Energy Dynamics website that talks briefly about the differences between 62.2 2013 and 62.2 2016. We're having sluggish internet connection today at our office, so I apologize if this is taking a minute. Here it comes.
Liz? Hello?
Where's that noise coming from?
The phone. The ASHRAE 60. Randy's talking to you.
Oh, hello.
Yeah, is there supposed to be sound with this?
Yes, there is.
So you might want to turn the sound on your computer.
The 2013.
Is the sound on your computer turned on?
Building 3 stories and fewer. That changed quite a number of changes. Standard, some terminology.
It comes through the computer, through your browser.
Changes to the
Yeah, it should.
You can leave it like that, you can hear it.
One thing that is part of the standard now is that there is a partial infiltration credit.
Rick Card says no sound.
Oh, shoot. I wonder why.
Can they hear it now?
I'm hearing the sound. This is Rick. I'm hearing the sound through the telephone now. You might want to take it back to the beginning. This is pretty short anyway.
Okay.
Drop down.
I will do that.
Yeah, we can hear it through the phone. If you just turn it up, we're all good with that.
Okay, you know what, I'm going to start it over because we are a little ahead of time, so.
Family buildings, there is no infiltration.
Why is it not?
Allowed. This horizontally
I did.
Partial infiltration.
Sorry.
All right, let's pull this down.
Duplexes, triplex.
And then drag it over to the beginning.
Okay, my apologies. I am going to start it over from the beginning, and we will let it go through the telephone.
This is Rick Card, Residential Energy Dynamics. In this short video, I'm going to point out the differences between the red tool for 62.2 2013 and 62.2 2016. There really aren't very many changes to discuss, but I want to make sure those of you that know the 2013 version well can watch this video and very quickly find out what the changes are. The biggest change to the ASHRAE 62.2 2016 standard is the inclusion of multifamily buildings of any height. The 2013 version of the standard included multifamily buildings of 3 stories and fewer. That change has brought a number of changes to the standard, some terminology changes, and some other things. The changes to the red tool are not as significant. One thing that is part of the standard now is that there is a partial infiltration credit for horizontally attached dwelling units in multifamily buildings. This drop-down has to do with that. The dwelling unit is detached, which is single family, or attached to other dwelling units. If I click that, notice another drop-down opens up. Only walls are in common with other dwelling units. This has to do with horizontally attached. If dwelling units are stacked, as they are in many multifamily buildings, there is no infiltration credit allowed. This horizontally attached partial infiltration credit is available for duplexes, triplexes, and row houses. Okay, a few more changes. The 62.2 2016 standard defines floor area a bit more clearly, especially for those of you that are wondering whether to include a basement or not. So you can check that out with the pop-up help for floor area. Because of the expansion to multifamily buildings in the standard, some of the terminology of the standard has changed. Dwelling unit in the 2013 version of the standard was termed whole building. So we changed the tool to reflect that. Finally, the last section of the red tool was added, actually it was added to the 2013 tool a while ago to reflect changes to the 2016 standard. Dwelling unit leakage rate solver. It will give you the corresponding measured leakage rate based on the characteristics of your building for any target mechanical ventilation rate that you add. For more information about these details and many more details, please take a look at the other video tutorials regarding the 62.2 2016 red tool.
Okay.
That shouldn't.
It's not letting me escape. There we go. All right. Okay. So, Karen, I need your help.
Okay, so.
I lost my screen.
Click that.
Really?
Wait, no. Click presentation right there. Yeah, right there. And there you are.
Okay.
Okay.
Thank you for bearing with me through this. Unfortunately, we had a little technical problem, but thank you for hanging in there. So, are there any questions about the differences? I don't see anything in the chat. I think it's fairly straightforward, and we'll watch the longer video, and after that we will go through some buildings with Rick together. So again, we're going to run this video without interruption, and we'll do the same thing that we just did. I believe that worked out for everybody, to leave the speakers on so you can hear the presentation. If you have questions, please go ahead and type them into chat. We will get to them as we can and save any that we feel need to be for Rick. Again, we're having a little sluggish. I feel a little bit like an airline pilot. Just wanted to let you know that we will be taking off shortly, and we're just on the runway taxiing. People usually want to know what's going on when things are slow.
This is Rick Carter, Residential Energy Dynamics. I'm going to walk you through the use of the red calc-free ASHRAE 62.2 2016 ventilation tool. This longer tutorial is for those users who have already watched the short tutorial but want to learn more about using the red tool in the ASHRAE 62.2 standard. If you're new to using red calc tools, please first watch these introductory videos. This red calc-free tool is for sizing dwelling unit ventilation in new and existing dwellings in both single-family and multifamily buildings. An important feature of all red calc tools is the pop-up help dialog box. Each input label, which is black font, and result label, which is always in blue font. If you click on those labels, I'll click on floor area now, you see a pop-up help which explains what the input or the result is. It also gives you ranges, allowed range, and the normal range. And you can disengage by Xing it out. If you're using a touch device, you just touch the label, the pop-up help will show, then you can exit out the same way here. Now before I make this pop-up help disappear, notice the allowed range and notice the normal range. If I go to living area and I enter 400, which is below the normal range, I get an exclamation point indicating that I am out of range and maybe I should check my values. On the other hand, if I make a serious mistake and enter -500 for the floor area, there will be a stop sign that will show, and this will not allow me to calculate anything until I fix my mistake. So one is a warning and the other is a stop sign. You will find with this red tool and many of the others, as you select and deselect items on the tool will expand and contract. Now, the last time you saw this, it was smaller. I have changed some of my selections, and now it is bigger. I am going to start at the top of the tool and work down. First of all, new or existing construction. The ASHRAE standard treats new and existing construction differently. As this selection is changed, the tool will change the things that show and the things that don't show. The example that I'm going to do, I'll do a couple of examples, will be for existing buildings. The next item, dwelling unit, is detached or attached to other dwelling units. This has to do with a new feature of the 2016 version of the 62.2 standard called horizontally attached dwellings in multifamily buildings. The default for this drop-down is detached. If, on the other hand, I select attached to other dwelling units, Notice that another input shows itself. Only walls are in common with other dwelling units, yes or no. Now, the default for this drop-down is yes. If I choose no, a number of things disappear because in this case, this is now addressing multifamily dwelling units that are stacked one above another rather than only attached side by side. So I'm going to go back now and click yes. So now this is set up to deal with horizontally attached dwelling units in multifamily buildings. The standard allows a partial infiltration credit for these buildings, and this has to do with duplexes, triplexes, row houses are a few examples. The next input is use infiltration credit. You can choose yes or no. Notice when I choose no, a great deal of the items in the tool, many of the inputs disappear because much of it has to do with the calculation of the infiltration credit, which is the most difficult calculation that is done with this calculation aid. I'm going to go back to yes. You should select yes if you're working on a new or existing dwelling and you wish to account for air leakage as measured by a blower door test. If you're using this tool for single-family detached buildings, we recommend you use the infiltration credit. However, if you're sizing dwelling unit ventilation for stacked dwellings in multifamily buildings, that is one above another, the 62.2 standard does not allow the use of an infiltration credit. So in that case, set this choice to no. The next section of the red tool is closest to weather station. Select either the United States or Canada. I've selected the United States. You can select one of the 50 states. I've selected Colorado. By the way, Washington, D.C. is not listed as one of the states. If you go to the state of Virginia, you will find Washington, D.C. Reagan Airport. So if you are working, living in the D.C. area, you will find Reagan Airport in Virginia data. And here you see for a particular state, you will see the cities that are listed for weather stations. I have chosen the Denver International Airport. After choosing those three drop-downs, we get the result of the weather and shielding factor of 0.59 for the Denver International Airport. This value is used for the calculation of the infiltration credit. While you weren't looking, I switched to another RedCalc tool, the Weather Station Data Tool, TMY. Stands for typical meteorological year. This can be helpful in finding the closest weather station to wherever you're working, even if it's in another state. What I'm going to do is turn on the weather map. This is a Google map, and you can see that the weather station that is selected up here in the drop-down menus is a red dot. The other existing weather stations, which I could select, are pink dots. If I select, for example, Boulder, you'll notice that Boulder moves to the center of the screen, and now Boulder is up here in the selected weather station. Let's assume that I'm looking at a house that is north of Fort Collins, maybe somewhere around where this Route 25 sign is. That is probably closer to Cheyenne in Wyoming than it is to the Loveland, Colorado weather station. So I could go ahead and choose Cheyenne. Without a map, you really wouldn't know which the closest weather station is. I'm going to go again to choose Denver. There are many other good things you might be interested in with this tool. There's a lot of interesting weather data, and you can find out the latitude, the longitude of the weather station, and also the altitude. We will use this value in a little while. Again, while you weren't looking, I switched back to the ASHRAE 62.2 2016 ventilation tool. I want to look now at the building data section right here, starting with floor area, where I have entered 2050. Now, that's not actually what I entered. I'll show you what I entered. I'm going to click on the input box here. This is a two-story house, as you can see from the dwelling height. And I've got 2 times one part of the house, 24 times 16, 2 times because it's 2 floors, plus 2 times the other section of the house, 32 by 20. This feature that we call Math on the Fly allows you to do your mathematics right in the input box. That's why this input box is so long, so you can do calculations like this. In it, if I click outside of the box, you can see you get the result of your mathematics. 2,050 square feet. Of course, you can change this with any of the red tools. We could change this to square meters. We get 190. I'm going to go back to square feet. Question that often comes up is, should I include a basement square footage in a house that I'm analyzing? The 2016 version of the standard clears this up a little bit. It states that if the basement is finished in a manner similar to the upstairs, it should be included in the square footage. Of course, the basement should also be a part of the pressure envelope of the house. Continuing with the building data section, I have scrolled the tool a bit. Next, number of occupants. You have choices here in the drop-down of from 1 to 10 occupants, as you can see. The standard does not allow 1 occupant. You need to have at least 2, but we put 1 in here so you can do what-if problems. Notice what happens if I choose 1. In the tool, a message appears to warn you that it's not compliant with the ASHRAE standard. I'm going to go back to 4 for my example. The standard allows you to increase the number of occupants over and above the number of bedrooms plus 1. And to do that, you merely have to add 7.5 CFM per occupant. The red tool takes care of that for you. The standard also says you may decrease the number of occupants from the number of bedrooms plus 1 if the authority having jurisdiction allows you to do so. So it's not as easy to decrease the number of occupants as it is to increase. To decrease, you need approval. The next input in the building data section of the tool is building height. The standard assumes 2.5 meters as the height for 1 floor. If you convert that to feet, that is 8.2 feet. Just in case you're wondering, I have put 17 feet in this example. The standard defines the building height as the vertical distance between the lowest and the highest above grade points within the pressure boundary. That's a very clear definition of what building height is. For simple houses, such as the one pictured here, this is quite easy to determine. On the other hand, it can be a larger problem, a bigger problem for more complex houses to figure out the vertical distance between the highest and the lowest above grade points. The last input in this section is the measured leakage at 50 pascals. I have entered 1400 CFM at 50 pascals, or CFM 50. This is a measurement you get from a blower door for the whole house. If the basement is included in your square footage, the basement door should be open for this blower door test. If the basement is not included in your square footage, the basement door should be closed. That is the door from the main part of the house to the basement. This is an important value. It is needed for the infiltration credit, just as the building height is needed for the infiltration credit. The next section of the tool is use advanced blower door inputs. Now, by default, this is not checked, and sometimes you might want to use this. I'll mention when to use it, when we recommend to use it, and when not to use it. In most cases, you probably won't want to use this. It'll take a little bit more time, and it makes the tool longer. But I certainly want to explain this. I'm going to check it. What we have here is the type of blower door test, pressurization or depressurization, indoor temperature. If you have a great temperature difference between indoors and outdoors, it's a good idea to go ahead and use this part of the tool. I'm putting down 68 degrees indoors and outdoors 10 degrees. If you want minus 10, you would put a minus before this number, 10. Altitude, remember this is the Denver, Colorado airport, and from the weather station data tool, I got a value of 5413 for the altitude. That's there. And of course, the temperature differences and the altitude have an impact on the density of the air, and that will affect the blower door test. So it's very important that you choose proper value here. Is it depressurization or pressurization? Because that affects your results. Notice if I click on pressurization, the resulting adjusted leakage at 50 pascals goes in the other direction. Our start is 1400. If it's a pressurization test with these values, it goes up to 1528. If it's a depressurization test, which is what most of us use most of the time because it's easiest, notice it goes down to 1300. The pressure exponent is something that you would use if you are doing a multi-point blower door test and you know what the pressure exponent is. If you do a single point, I suggest very strongly you leave this alone. Leave it set at the default of 0.65. Here is the adjusted leakage right here from 1400. Now, if we unclick this, our calculations will use 1400. If we click it, our calculations for ventilation will use this adjusted values. Notice when I unclicked and clicked, the same values stayed here. Now, as far as when should you use this section, we recommend that you use it if you have a significant temperature difference, say more than 40 degrees between indoors and outdoors. Use it if you are at a significant altitude, or if you have done a multi-point blower door test and you know your pressure exponent. Otherwise, it's probably best just to leave this section alone. It will make your calculations a bit easier. Next, I'm going to talk about the alternative compliance path of the ASHRAE 62.2 standard. That is covered in the Use Local Ventilation Alternative Compliance section of the RED tool. The alternative compliance path is allowed for existing buildings only that do not meet the 62.2 standard prescriptive requirements for local exhaust ventilation fans in kitchens and bathrooms. These prescriptive requirements are 100 CFM exhaust fan in a kitchen that is demand controlled, and for bathrooms 50 CFM exhaust fan that is demand controlled. The alternative compliance approach requires that you increase the flow rate of the dwelling unit ventilation in order to compensate for the deficiencies or the deficits in local kitchen and bathroom exhaust ventilation. Using the alternative compliance path is not best practice, but it can save a lot on installed costs. For the details of the alternative compliance section of the RED tool, first of all, you can select or deselect the kitchen, and notice I have entered values here already. If I deselect the kitchen, you can see it goes away. If I select it, the number I've already entered is there, 65. And then for bathrooms, I can select anywhere from 0 to 5. If I select 5, notice what happens. There's a default in there. It says enter 0 if there is no ventilation in that particular room. That's a reminder. Don't leave it blank, but enter 0. I'm going to go back to 2 for my example, 2 bathrooms. Then in this part of the table, I have the fan flow. Now, the ASHRAE standard states that the fan flow must be measured. The existing fan flow must be measured. So that's what we have here. Does it have an openable window or not? If it has an openable window, that has an impact on the total deficit over here. Now notice with the kitchen, if there's no openable window, the deficit increases to 35. An openable window allows you to decrease the deficit by 20 CFM. You can see as I clicked it, that happened here. Kitchen, 65, I measured it, has an openable window. I check that. Makes no difference whether it has 1 openable window or 7. I click this and I get a credit toward the deficit of 20. Bath number 1, I measure it. It has a fan flow of 25 CFM. Bath number 1 has an openable window. It has a total deficit of 5 CFM. Bath number 2, I measure the fan. It has a CFM of 30. No openable window because it's on the interior of the house. Therefore, it has a deficit of 20. And the entire deficit, all of these added together, adds up to 40 CFM. Now for the dwelling unit ventilation results. By the way, before the 2016 version of the 62.2 standard, this was called whole building ventilation. First of all, effective annual average infiltration rate. This is a value that you get from your blower door test, and it's an averaged constant flow rate that has the equivalent effect on air quality as the real year-round ventilation infiltration rate. So that's the infiltration. Next, an important number is the total required ventilation rate, or Q-tote. Now, Q-tote comes from the equations that are now listed on the slide as an overlay. Q-tote is the total amount of ventilation that we need. This will be made up of natural air leakage and mechanical ventilation. Next is the alternative compliance supplement. That comes from the alternative compliance path section of the tool just above. And remember, for our example, the total deficit was 40. We divide that by 4, and that gives us 10. So that number gets added to the 91 from Q-tote. So now we have 101. Next is the infiltration credit. This comes from our blower door test also, and it is Q-inf for infiltration. And for existing homes, this value, 58 CFM, will always be equal to this value, the effective annual average infiltration rate. However, for new homes, the infiltration credit is limited to 2/3 of Q-tote, this value right here. So we have 91. We add the alternative compliance supplement to that. We subtract the infiltration credit amount. This is the amount that is coming from natural air leakage, and the remaining amount is the required mechanical ventilation rate, or Q-fan. For this example, that is 44 CFM. Once you have your calculated results in this section of the tool, you can then move on to the bottom 2 sections of the tool. First of all, dwelling unit ventilation runtime solver. This section of the tool calculates the required runtime of your ventilation if you don't operate the fan continuously. For example, our problem determined that we needed a dwelling unit ventilation fan of 44 CFM. Well, what can we do? Chances are we can't get a 44 CFM fan on the market. the fans are usually bigger. We could buy a 90 CFM fan with a capacity of 90 CFM and use a variable speed control and bring it down to 44 CFM. Another way of getting the ventilation we need each hour is to run the fan intermittently. That's where this section of the tool helps you. For example, let's assume that the fan we buy has a capacity of 90 CFM. We put that in this input box right here, and then the result tells us that the fan run time per hour is 29 minutes, or we could just say 30 minutes. So if the fan runs for 30 minutes, it's off for 30 minutes. That satisfies the requirement, the minimum requirement of 44 CFM by the ASHRAE standard. This last section of the 62.2 red tool calculates the corresponding measured leakage at 50 pascals for an entered target mechanical ventilation rate based on the dwelling characteristics. This section is intended to determine at what leakage rate value the required mechanical ventilation will equal 15 CFM based on a provision of the 62.2 standard that does not require dwelling unit ventilation to be installed if the calculated Q fan is 15 CFM or less. Now remember, I passed over it quickly, this resulting value is based upon the characteristics of the building, the number of people, the height, the weather factor, and all of that. So here I have 15 CFM entered, and if you have a required ventilation of 15 CFM or less, you don't have to install any. This tells us that the corresponding leakage rate is 2100. Well, for our particular building, we have 1400. I'm going to scroll up here, and you see right here we have 1400. So we're not going to go ahead and make the building looser. So this is nice to know, but this building is tighter than 2100, and we can't do anything about that. You could enter any number in here, for example 0, and you can see that you'd end up with 0 ventilation for the characteristics of the building if your corresponding leakage rate was 2500. I'll go back to 15 here, click outside the box. Again, you see 2100. All right, before I finish, there is one thing I said I would go back to. That is the infiltration adjustment for horizontally attached multifamily. Remember, if the multifamily units are stacked, that is one above the other, there is no infiltration credit allowed. So in that case, you would have to choose no right here. But if they are horizontally attached side by side, then you would choose attached to other dwellings. There's another input that appears, a drop down. Only walls are in common with other dwelling units. And that has to be yes to be able to take this credit. And if those drop downs are engaged, you will find then further on down in the tool there are some other inputs that show, and you must fill these in. I moved away from the tool to explain what's going on here using some pictures and illustrations. Our example house that we've been using is about 2,000 square feet, just over that. And for now, let's assume that instead of being a detached single-family house, it is attached horizontally, in a horizontally adjacent way as these row houses are. Let's assume it's the same size, it's 2 floors, and just over 2,000 square feet. So let's look at the horizontally attached infiltration credit adjustment. First of all, you have to do a blower door test of the unit. What's different about horizontally attached units and a detached unit is that with horizontally attached, some of the surface area is in common with units next to. So we have to do a blower door test, and we do an adjustment to take account of the common attachments, the common walls. We calculate the fraction of the enclosed area, the 6 sides, that is not attached to other units or garages, and that's what we take as our infiltration credit. We multiply the infiltration estimate from the blower door test by this fraction, and that shows in the equation right here. Q fan, or the amount of mechanical ventilation we need, is equal to Q tote minus Q filtration. This is for detached, but when we have horizontally attached, then we have this value here, A sub exterior, or A sub X, which is equal to the exterior surface over the total envelope surface. Again, the exterior surface over the total envelope surface. You'll find for our example, this ends up being 80% or 0.8. So we're only allowed to take 80% of this amount and subtract that from Q tote, so Q fan goes up. So let's look at an illustration of what we've got for our horizontally attached row house. The one in question is the light green one in the center. Here's our equation that we just looked at. So let's look at this piece by piece. Let's say this is a triplex or row houses, 1, 2, and 3, and they're 40 by 25, 8-foot ceilings for each story, 2 stories tall. The 1,000 in each of these cases is the ceiling and the floor, 1,000 square feet, which is 40 by 25 for each of these 3 units in this multifamily building. Again, we're looking at the central one. The front and back turns out being 640 square feet. That's also exposed to the exterior. Now these end values, this is an end wall, 400 square feet. Here's an end wall down here, 400 square feet. But for the center unit, the one in question, we have 400 square feet and 400 square feet of wall in common with the adjacent units. So the total surface per unit is listed here, and if you want, you can stop the video and check my figures here and try to figure this out. It's rather complex. The infiltration adjustment we have here for the end units, this one and this one, we multiply Q in by 90% or 0.9, and for the middle unit that we're using in our example, A sub exterior is 80% or 0.8. So that's how we figure it out. Now you can see this is rather complex. The nice thing about the red tool is it does all of this for you. You still have to do some measuring and enter the values, add some things together. But remember, you can use the math on the fly of the red tool. It helps you out. Continuing the horizontally attached multifamily dwellings in the red tool, our example so far has been with dwelling unit is detached for the horizontally adjacent units. I'm going to select this and the dwelling unit is drop down. Then a new thing appears, only walls are in common with other dwelling units. The default choice for that is yes. And then as we scroll down past the weather station data, that's going to stay the same. The beginning of the building data, we're leaving all those the same. But then this new area appears when we select the drop-downs for horizontally attached dwelling units above. And from our illustration that we just looked at, the area of common walls, we're looking at the center of the 3 row house units, 800 square feet. Envelope area of adjoining garages, we have 0 for that. And then the remaining envelope area, 3280, which gives us a total of 4,080. Now that has an impact on the infiltration credit. Remember, with the illustration, we came up with a a sub-exterior value of 80% or 0.8. So now you see our infiltration has gone from 58, we still have that value up here, but we take the 58 and multiply it times 0.8, which gives us 46 or 46 CFM is what we get for the infiltration credit. So the infiltration goes down, which means a larger portion of Q tote has to come from mechanical ventilation. So our mechanical ventilation goes up to 55 from 44 that we had with the single-family detached dwelling. So I hope this shows you how the horizontally attached infiltration credit feature of the RED tool works. And of course, the RED tool is based on the ASHRAE 62.2 standard precisely, so you can be confident that everything that you do with the RED tool will comply with the ASHRAE 62.2 2016 standard.
Mm-hmm. And close. Present PowerPoint. Yeah. There you go.
Okay, we're back live. That was the long version of the tutorial. So our next task will be to turn the presentation over to Rick Card. He's going to enter some building data live. You will be able to chat in some questions. And we have also asked him to explain how to use the RED tool when you're not online by downloading it onto your device prior to the inspection. So Karen's going to help us turn this over to Rick now.
Good afternoon, everyone.
Hi, Rick.
This is really
Good afternoon,
me.
Rick. You're not a robot.
I am not. Let's see. Okay. Going to try to do this the right way. Are you able to see my screen?
Yes.
Yes.
Okay, it's a map. Okay. A few questions came in. Al just asked a question, and I'm going to address that right now because the video just addressed the horizontally attached units. And Al's question, Al, please tell me if I've got this right. If there are horizontally attached units, however, there are also units above another. They're horizontally attached and they are stacked. Is that your question, Al?
It is.
Okay. If that's the situation, because of the fact that they are stacked, no infiltration credit is allowed by the standard. So what you would have to do on the tool, I'm going to drag the tool in front of you, you would have to just click no there. Use infiltration credit, no, and that would go away.
Okay.
Okay?
Thank you.
Thank you. Yes.
And if you're not using an infiltration credit, you can see that most everything in the tool disappears, and that's to prevent you from entering something that's not needed or does not correspond with the ASHRAE 62.2 standard. Notice that there is no place now to enter a blower door number. So a blower door value is only needed if you're taking an infiltration credit. So if you've got multi-family units, there's no blower door required. It's merely the ventilation rate is based upon the floor area and the number of occupants, and that's it.
Thank you.
Okay, so something else I wanted to, as I was listening to myself talk in the video, I'd never really looked in detail at what I brought out in the video about using the weather station data tool for parts of Maine where there might not be a weather station that's close. And as I look at this, so this is the map of Maine, a Google map, I am noticing, we notice the pink dots, those are where the weather stations are. I think there are 15 in Maine now. And the selected one up above in the closest weather station drop-downs for Augusta, so it's red. But I hope you can see the little hand on the map. This is where I live, right here in Bethel, Maine. And you can see that there really is the closest weather station to me is Berlin Municipal Airport in New Hampshire. So if I were doing an analysis somewhere in my area here, the best thing for me to use would be the Berlin, New Hampshire weather station. And it's good to ask yourself the question, if you go across state lines for this, is Berlin a lot like Bethel in terrain and all of that? And the answer is yes. I would not choose the Mount Washington weather station, which is the most severe one of all 1,100 weather stations in North America because of its high wind. So that one you just leave alone. You never choose that, even if you're right in this area of Maine. It'd be best to choose Berlin. And another place that comes to mind is in southern Maine. I think this is York County down here. Here is one in Sanford Municipal Airport. If I'm right down here in the southern tip of Maine, it would be best to choose the Pease International Trade Port right here. So something I thought I would mention. Maybe some of you are on the line that might want to use those. Otherwise, if you look at other spots in Maine, the weather stations in Maine should be just fine. So I'm going to take that off here and open up the slideshow and go over the major change. I hope you can see the slides. Let's start at the beginning. The slides address the major change, and I've got some other questions that came up during chat, and I'll be happy to answer any question I can when I'm finished with the slideshow or during the slideshow. If you want to interrupt me, then go right ahead. And Liz, if you would remind me to talk about the using the red tool offline. Okay. I've written it down, but I want to make sure I don't forget that. Okay. So just a few slides to go through. I'm going to address the infiltration credit in multifamily units a little bit more. Now, this fortunately is, for most of you listening, I think a sideline. Most of what you deal with is single-family detached units, and you really don't have to do anything unusual with that. There's really no change from the 2013 to the 2016 ASHRAE standard and red tool. And if you wonder about that, you can always run a house on the 2013 red tool and then run the same house on the 2016 red tool. And if it's a single family detached house, you'll get exactly the same answer. That's a good thing to know. So some questions for you. You don't have to unmute yourself to answer these. Is an infiltration credit allowed for this duplex? And answer that question, if you will, silently, or you can shout it out in your office or wherever you are on mute. But this is a duplex that these are horizontally adjacent, horizontally attached, horizontally adjacent. they are not stacked. So because they are horizontally connected by a common wall, a partial infiltration credit is allowed by the ASHRAE standard. That was not the case with the 2013 version of the standard. For a duplex with the 2013 version of the standard, no infiltration credit was allowed. Now here we have a triplex, but in this case they are not horizontally attached, they are stacked, one above another. So what they have in common are floors and ceilings. And according to the ASHRAE standard, no infiltration credit is allowed in this case. And by the way, if any of you are typing into chat, I'm no longer looking at it. So maybe Al or Liz, you can look at it, or just unmute yourself and ask me a question. I'm making a note right now. Something I want to tell you. Okay, so no infiltration credit is allowed here. And with this one, we have a triplex again, and we have, these units are on, each unit is on 3 floors. Garage is primarily the first floor, living area, then bedrooms on the 3rd floor. Is an infiltration credit allowed here? Question to ask, is the only common building assembly walls? And if that's the case, then a partial infiltration credit is allowed. You can go through that on the red tool, and we will do an example, another example. There are no stacked units here, so this is allowed a partial infiltration credit. So just to briefly go over what the video looked at, this is the way in the ASHRAE standard, this is right out of the ASHRAE standard, this equation, the Q-fan equation is right from the ASHRAE standard. How is it calculated? We do a blower door test. Now, the standard does not specify how to do the blower door test. Let's assume that you are looking at a duplex or a triplex, and you're looking at one of the units, what's the best way to do a blower door test? Some of you might know what a guarded blower door test is. It's one of 3 ways you could do a blower door test in a horizontally attached building. Let's say you've got a duplex and you want to do a guarded test. To do a guarded test, you would need 2 blower doors. You would depressurize each of the units to -50 pascals. And what that does then, for the one that you're concerned with, the subject unit, it eliminates any leakage through the common wall. So then you only have leakage through the exterior walls. That's one way to do a blower door test on a duplex. Another way is to open the windows in the duplex, in the unit, the living unit you are not interested in. Of course, close the windows and doors on the one you are interested in. That would change your number. And then the third way is to close the windows in both of the dwelling units, the one you're interested in and the one you're not interested in. In all 3 cases, you are going to get a different number, a different blower door number. Unfortunately, the ASHRAE standard doesn't tell you how to do the blower door test. And that's something I intend to bring up in committee meetings and propose a change for that. But right now, do it any way you want. What I suggest is that as a program, the weatherization program in Maine, at one of your technical committee meetings, you decide how to do this, and then everybody do it the same in the state when you have multi-family units. Remember that the higher the infiltration number, the higher the blower door number, the lower the mechanical ventilation rate will be. So you might want to keep that in mind when you decide how you are going to do the blower door test. So you do a blower door test, you calculate the fraction of the enclosure area, 6 sides, that is not attached to the other units or garages. Now, every enclosure area, every duplex unit or triplex unit or whatever has 6 sides. It's got a ceiling, it's got a floor, even if it's a basement floor or a slab floor, and it's got 4 walls. So all of those would be included. There's a format for you to enter those values in the red tool, and we will go over that. Multiply the infiltration estimate from the blower door test by this fraction. Well, we get a number here. Oops, I didn't mean to do that. We calculate A exterior as it mentioned in the video. So here we are. And let me just get a sense of where I am in the, I'm sorry about this. Okay. So this is a repeat of the video showing there are the ceilings in this triplex, the ceilings, 1,000 square feet each, the ceiling and the floor, adding up to 2,000. And the back walls and the front walls, 320 each, and the end walls. So that's how this would be measured. Don't forget to measure the floor. So the total surface, as you saw in the video, and you can go back and look at that video anytime you want. It will stay online for you. So you can see we've got here, we've got the N unit gets 93%. Now what that means is that 93% of the end unit is leaking to the outdoors, and the remaining part of that, about 7%, is leaking to the other unit. What we're trying to do with this procedure is eliminate this leakage. And then the middle unit gets the 86, as you can understand, because it's got 2 common walls. So it gets a smaller percentage. So that's quickly the procedure. Now let's do an example specifically for this duplex. In the example, I have ignored this punch-in entry here. I'm just assuming it's not even there to square the building off. So it's a duplex side by side. So what we've got, I'll just go over the numbers here, then I'll bring the red tool in front of us. Here's the floor area for one of the duplexes. I'm assuming that the basement would be included as part of the floor area. This can be a big question. This is something that the ASHRAE committee is working on, but is finding is a difficult issue, whether to include a basement or not. So floor area, one floor is 780, and we've got 2 of those, the floor where the major living is, and then the basement. The basement is included. 3 bedrooms, it's in Augusta, so that gives us other data we need, the weather station to use, and if it's 3 bedrooms, that means it's 4 occupants. The blower door number for one unit is 800 CFM 50. The height is 16 feet. Now, height, square footage, floor area is one question that comes up a lot. Another one is the height. Now, I'm just going to take a moment here to bring the tool over And what I'm going to do is click on the label building height. If you're using a tablet or a smartphone, you would just touch building height. I hope you can see what it says here. This is, excuse me, pretty much right out of the ASHRAE standard. It's the vertical distance between the lowest and highest above grade points within the dwelling pressure boundary. Notice it's pressure boundary, it is not thermal boundary, pressure boundary. So that is where the building height comes from, and floor area in the current version of the ASHRAE standard, all enclosed above and below grade finished areas suitable for year-round use. Include basements or parts thereof only if they are finished in a manner similar to the rest of the dwelling. That is the current definition in the ASHRAE standard. So that means that part of the basement might very well be included in the floor area and part may not be included. That certainly causes a challenge if you're trying to do a blower door test. If the basement is included in the floor area, then the basement door should always be opened when the blower door test is done for purposes of calculating the ASHRAE standard. Understand that the blower door of record that you put in Hancock to calculate energy and potential SIR for air sealing might be a different blower door number than the one you used for putting in the red tool for calculating the ventilation rate. So any questions about floor area or height before I move on? If there are, please unmute yourself and just ask the question. Okay. So we have the height here. It's 16 feet because there's a walkout basement in the back.
Hey, Rick?
Yes.
Rick, this is Al.
Yes. Yes, Al.
Randy Burgess had a question about the stacked multifamily units.
Yes.
His question is, for stacked multifamily building that has multiple levels, what do you use for building height?
That's a good question. For stacked multifamily, what you're doing is using, and the standard really doesn't cover that well. I don't think I've ever been asked that question before. And
all right, good question.
Yeah, and I can't believe I've never been asked that question, nor have I ever thought of it myself. So, great question. In that the standard should specify this because you can do this in different ways. What I would suggest you use is the height of the building. Say it's a 3-story stacked multifamily and you're dealing with the top unit on the 3rd story. I suggest what you do is use the height of just that unit on the 3rd story. So let's say it's 1 floor and it's 9 feet. I would use the 9 feet. However, you can make a fairly strong case for using the height measurement from the ceiling of that 3rd floor unit to the ground level, because what we are after here is stack effect infiltration,
right,
technically speaking.
right.
But let me show you something. I've got the tool. This kind of overrules everything I just said. If you are, this makes it a moot question. In that case that Randy mentions, these are stacked multifamily. So
right.
watch what happens. So no infiltration credit is allowed. So what I'm going to do is click no,
Yeah.
and notice height is gone.
That's what I was wondering if that would happen, because I remember you said if they're stacked, you don't get an infiltration credit, and the height is used to help calculate the infiltration credit.
Yes.
So actually, you have dealt with this. You just didn't remember that you did.
I didn't remember. That's right. That's right.
But
Many
Rick,
of you know I'm getting older. Yes. And the only reason we need height and weather station is if we are taking an infiltration credit. And if we're not, we don't need a blower door number, we don't need height, we don't need the weather station, because the weather station also has to do with the way infiltration is dealt with. The blower door number is interpreted, and it helps us determine the air leakage. So no infiltration credit, many things disappear. So Randy, good question, but we really don't need to ask that question because it's not relevant with the way things are calculated. So I hope that answers.
Thank you.
Yeah.
Thank you, Rick.
It's still a great question. I like the question. So we've got the height. The area of the common walls for this duplex is 480, 30 feet, which is from front to back on the duplex, by 16 feet high. This includes the basement dividing wall, the basement common wall, and the first floor common wall. And then the total envelope surface, which is something that is needed. And this takes measuring. There's no way to get around it. You're going to have to measure. Everything is included here, and we get a total of 3352. And then the remaining envelope area of the tool is 2872. Now notice this is in quotes, remaining envelope area, and area of common walls is in quotes. That's because both of those are entries in the red tool. We'll look at that in just a moment. 480 plus 2872 is equal to 3352. So the common walls plus the remaining envelope area equals the total envelope surface. So these values are used to calculate the A exterior fraction. So we'll look at the red tool now and work through this. And this is the time as I go through the tool. I hope, can you all see the details on the tool? I hope so.
Yes.
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 Okay, so the red tool is in sections. This is one section right here and another, and some of the sections are turned off, such as advanced blower door inputs. If I click this, it would open up. Alternative compliance is turned off. You will usually use that, and this is the results down here. So we'll continue with the example. So new or existing construction, you see that you have a choice here. And for you, I can't think of any circumstances where you will use new. I know that Community Concepts for a while and some other agencies had new home programs. In that case, you would use new. But most of the time, you will use existing. And most of the time, the dwelling unit is detached. This is new for the 2016 version of the standard. And for our example, we're gonna use, it's attached to other dwelling units. Now, with Randy's question that he brought up, and I said, okay, how about a 3-story stacked multifamily building? In that case, you would just hit no there. No infiltration credit is allowed, and you can see there really isn't much to do to calculate the infiltration rate anymore. But you can still use, in that case, the local ventilation alternative compliance feature. So I'm going to go back to yes, we want to use the infiltration credit, and that is to your advantage whenever you can, and to your client's advantage. If it's the duplex that we are working on, it is attached to other dwelling units. Are only walls in common with other dwelling units? Yes. In Randy's example, the answer would be no. I just hit no, and you can see infiltration credit automatically goes away. But for us, because this is a duplex, a side-by-side duplex, I click yes here, and I am entitled to an infiltration credit. The house is in Augusta, so I have chosen United States. This has got Canada in it. United States, Maine, and Augusta. And this is the weather and shielding factor right here. The weather and shielding factor for Mount Washington, just by comparison, I think is 1.51. If you go to the southern states, there are some of them that are 0.3. It gives you a sense of what that happens to that number. The floor area from my example is right there, 1560, and I could do this math right here, looking at the slide, in this space, math on the fly. For example, I think I can do this and still look at this. If I want to do the math here, 780 times 2, and then I hit enter and I see 1560, same thing. So hit enter or click outside of the box is 1560, but if I click inside of the box, I can see the mathematical expression I put in the box. That's why this box is so long, so you can do math on the fly here if you want to. So you can do that in almost all of the boxes where it's appropriate. Building heights, you can do it there. You can do it here in area of common walls and many other places in the red tools. So I'll bring this back up here again. So area of the common walls, this is a measurement. Oh, I'm sorry, I've got the number of occupants, 4, there are 3 bedrooms, and the dwelling height is 16 feet. You can change units if you want. I don't know why you would want to do that. It shows you what that is in meters. Area of common walls, 480 square feet. Envelope area adjoining a garage in a building like this, that would be here. By the way, if I say that this is detached, notice that the section of the tool we were just looking at goes away. Now I'm going to go back. That's so you don't fill it in unnecessarily and make mistakes. So here we are again. Here it is again. Remaining envelope area, 2872. And those correspond with this value, area of common walls, and remaining envelope area. So those are entered here. And you just have to do measuring. No way around it. So the total envelope area is here, and this figures out, although you can't see it, it figures out the value for A exterior right here, which is 0.86 or 86%. Now what that means is that 86% of the surface area of this duplex is exposed to the exterior, and the remaining percentage, 14%, is exposed to the adjacent dwelling unit. So we're eliminating that and reducing the blower door value by that amount, assuming that that's giving us a good idea of what the leakage would be if that wall weren't there, which is certainly open to a lot of questions. So the measured leakage, you do the blower door test. I mentioned there are three possible ways for doing the blower door test. Here we do the blower door test. I'm not sure how we did it. I can't remember. But we end up with 800 CFM50. 800 CFM50. So that's where we are. We've gathered a lot of data. Question came up during the video. When might you use this advanced blower door inputs in Maine? It's really not an altitude thing in Maine. There aren't a lot of high altitudes that change the density of air much. I would say that if it's really cold outside, it's probably a good idea to use this because it will adjust it accordingly so that in more normal temperatures, the ventilation rate is calculated as it should be. So I don't know. I would say this, I'm just pulling this out of my hat. If it's below 20 degrees, I would suggest you use this. So for indoor temperature, especially if it's a loose house, by the way, the indoor temperature we'll say is 70, and the outdoor temperature is -10. And click outside of those boxes, you can see what it does to the blower door number. The actual blower door number. Remember from the video, now that number with this box checked right here, that 693 CFM50 adjusted will be used for calculating the ventilation. If I unclick this box, the 800 will be used to calculate ventilation, and you can see it's gone down. But if I unclick this, those entries are still there. Another time you might use this in Maine is if you do, for some strange reason, do a multi-point blower door test and calculate the pressure exponent. Let's say it is 0.7, and notice that changed the number. But I've really never heard of anybody in Maine routinely doing a multi-point blower door test. Now, if you use Tektite, I have seen that. If you use Tektite, it does it automatically, and it does generate for you the pressure exponent. I would then use this section of the tool and put the pressure exponent in there. But that pressure exponent should be the post-weatherization pressure exponent. When you weatherize a house, when you tighten it, the pressure exponent will usually change. So it will usually go up. So it gets kind of complicated. The best thing might be just to leave that alone. So I'm going to get out of here now. So this is the effective annual average infiltration rate, 32 CFM, and we are taking 86% of that as calculated right here on the slide. It does not show that 86% on the tool. You could figure it out. That ends up being 27 CFM. So what we're doing is saying that of the total amount of fresh air needed in this unit of this duplex, Q tote, that value is 77. That's what we need based upon square footage and number of occupants. 27 of that we're going to get through infiltration on average over the year. So we must supply 50 as the required mechanical ventilation rate, or Q fan. Q tote comes from two places, both natural infiltration, or the infiltration credit, that's what we use to calculate that, and mechanical ventilation. So for this duplex, without using alternative compliance, we need a dwelling unit ventilation rate operating all the time of 50 CFM. Now, if we're installing a fan that has the capacity of 90 when it's running, this part of the tool is a little add-on. It tells you that the fan runtime each hour needs to be 33 minutes. So that's intermittent operation rather than continuous operation. If we go with continuous operation, we need 50. So this 50 is used in the calculation of this runtime right here. We have to put the capacity in. Of course, if the capacity is 120, if the fan runs at 120 when it does run, now it's not going to have to run as much during 1 hour, only 25 minutes. So you would set it accordingly. So again, if you have questions, just speak up. I don't know. Do my best to answer them. So now,
Rick?
what if we, yes.
If you go back up to the top of the tool,
Yes.
all the way back up to the top.
Yep.
If you have row houses that are also stacked, in other words, you have 3 horizontal connected units, and then you have 3 on top of them, how do you answer the question, only walls are in common with other dwelling units?
Like this. No.
Right.
No. Okay.
Because you would have ceilings in common.
Right, and that's why I wanted him to point that out.
Right.
Yeah.
The walls
Yeah.
are, you do have walls in common, but it's not only the walls that are in common.
That's right.
Okay.
And we try to be thoughtful when we come up with statements like this, and the ASHRAE standard really doesn't include language like this. There's a lot more language there to tell you how to use this, but the key, the key to this is only this, this particular line here.
Okay.
Only is really important.
Yeah, that's what I wanted to clarify, just to make sure that that's what that was the operative word there.
Yeah. Thank you.
Okay.
Well, that's good. So now what I'm going to do is open up the alternative compliance section. It's very likely if you do a house like this in Maine, a duplex like this, you will use the alternative compliance feature because it can help you out. For an existing home, you may use alternative compliance, or an existing dwelling unit in a multifamily building. You may use it. You may not use it for new dwelling units, whether they are detached or multifamily. You can only use it for existing, and the primary purpose of the alternative compliance path, which is Appendix A in the ASHRAE standard, is for kind of save your butts in low-income weatherization, because otherwise you'd have to be putting a 100 CFM kitchen range hood in most kitchens and a 50 CFM fan in all bathrooms, and that's a lot of money. So this is a way to save you money, and if this duplex has no kitchen fan. And by the way, this was mentioned in the video. There's a placeholder here. It says enter 0 if none. And Randy Burgess asked a question during the video, when would a kitchen fan not be a part of an analysis? Well, in my opinion, Randy, it's always part of the analysis. In this case, if there is no kitchen fan, I would put 0. And you don't have to put a kitchen fan in if you're using the alternative compliance path, but notice what it does. There's a deficit of 80, and I'll mention that in just a moment, mention a little more about that. But so you don't have to put a kitchen fan in. These numbers, whatever you put in here for kitchens and bathrooms, and as you know, it can be up to 5 bathrooms, these values should be the values for the flow rate of these fans when the job is done. That's really important. There's been a lot of confusion over the years since this first was put in the standard in 2010. People will go to a house and there's no kitchen fan, so they'll put 0. Even if they install a kitchen fan, they'll leave that at 0. Well, if you install a kitchen fan as part of your weatherization work, then this should be 100. Or if you install a kitchen fan that's 160, put in 160. That's fine. It doesn't recognize anything above 100, but notice what happens now to the deficit when I click outside of that box. The deficit in the kitchen is now 0. So these values should always be the values, the measured values when you are done with the job. So whatever this happens to be. So notice if I put in 100, it doesn't change anything. This remains 0. But I'm going to take this back to 0. Say, well, there's no kitchen fan there, and man, there's no kitchen range hood. We just can't get one in without spending $1,000 or $800, and we don't have the money to do that, so we're not going to put one in. So there's a deficit then of 80 in the kitchen. It's actually a deficit of 100, but the deficit can be reduced by 20 if there's an openable window, or 3 or 4 openable windows. Doesn't make any difference. We can only reduce it by 20. So let's say in the bathroom, we're going to put a double duty fan there, a fan that runs all the time at the dwelling unit ventilation rate, and the speed goes up when we walk into the bathroom to cover the local ventilation. It's a double duty fan. So with this in mind, what we are leaving in this house after the weatherization, we have a total deficit of 80. That is divided by 4 and added to this value here. So 80 divided by 4 is 20. That's right here. That's the alternative compliance supplement. That's something we called this. There's no word for that in the ASHRAE standard, but the supplement. So we have 77 is required based on the number of people and the square footage. Because we have a deficit in local ventilation, we have to increase that by 20. Now we're up to 97. We can decrease that by the infiltration credit. We subtract 27 from that, and we get a required mechanical ventilation rate of 70. So that's how that would be calculated if we use the alternative compliance approach. And you might say to yourself, well, gee, why use the alternative compliance approach? Because the dwelling unit ventilation rate was 50 What's the benefit of using the alternative compliance approach, because now it's gone up to 70? Well, if you use it, you don't have to put in a local kitchen fan. And if you don't use it, yeah, your dwelling unit ventilation rate is 20 lower, but now you have to install at least a 100 CFM range hood or a 300 CFM fan in the kitchen that's not a range hood. That's something new with the 2016 standard. Yeah, good thing to avoid.
And then you'd have to put in a sealed
Gen Air.
combustion
You have to put a Gen Air.
Yeah, yes, the Gen Air has to be at least 300 CFM, and they are anyway.
Yeah.
So I've gone through the tool, I've gone through this particular example, and I've tried to point out parts of the tool that are even a bit unrelated to the example. Are there any remaining questions before I cover a few other things?
I don't see any on the chat.
Okay. I'm going to tell you now how to use this tool or any of the other red tools out in the field where you have no internet connection. And I know, especially for some of you in Maine, that happens quite often. We do not guarantee that the tool will work, but I've never heard of a case where it won't work if you do what I'm going to tell you. Although we decided that we will not put this in writing just because we can't guarantee it. Now, we are now working on a new website and new tools that are mobile first, and we're also working on RedCalc Pro, which will be available by subscription only. We're not going to take away RedCalc Free. RedCalc Pro will just have more features like collaboration, and we will guarantee that it will work offline, for example, and you can do reports and save files and all of that, which you cannot do with RedCalc Free. But RedCalc Pro will work offline, but here's how to do it with RedCalc Free. And if you can take notes, you might want to do that for this. There are not very many steps. First of all, if you know you're going to use a particular tool out in the field that day, like this one, 62.2/2016, load it on to the device you're taking out in the field before you go out in the field while you still have an internet connection. So if you're using a laptop, open your favorite browser. We prefer Chrome, but open your favorite browser and load the tool. I'll make this look more realistic. I'll make it even more realistic. Let me see if I can do this here. I'm using a special features, but this is what it looks like for you. So you would open this up on your laptop or your tablet or your smartphone when you go out in the field. So before you go out, you load it up. If you think you're also going to use the ZPD tool, well, you probably won't do that, but I'm just going to show you what to do if you're going to use that too, or another tool. So now notice, I hope you can see it, I've got two tabs on my browser. Both of these are open. If you want to open 5 red tools before you go out in the field, that's fine. Then you'd have 5 tabs. So here's the 62.2 tool, as I just used it. So now I can go out in the field and use this and change things as I'm doing now. I can, by the way, you'll probably not need to change the closest weather station, but you can change things as long as you avoid two things, and this is important. So now, let's say you're using a tablet. Is that what you use for a Hancock? Use tablets?
Yes.
Mostly tablets,
Okay.
and a lot of people do use their smartphone too.
Okay, let's say you've got a tablet out in the field and you've loaded this into the browser. Maybe that's Safari, which is the Apple browser. You go out in the field and you can use this all day long. As long as you do not hit the reset button right here. Don't hit the reset button, because if you do, it attempts to communicate with the server. And if you're out in the field and don't have a connection, it can't connect with the server. So you'd be stopped in your tracks. The other thing that you should not do is refresh the screen. I'm at the upper left now. This is where the refresh button is for Chrome. Don't try to refresh the screen, because again, it tries to communicate with the server and you'll be stopped in your tracks for the day. So as long as you don't hit the reset button and the refresh button when you're out in the field without a connection, it should work fine for you. And what you'll have to do is just change things for the particular job, which is probably what you do anyway, rather than hitting reset. If you hit reset, it clears your entries. Maybe most of you probably never hit reset anyway. So just leave that alone and leave the refresh button alone, and you'll be fine out in the field. Now, if you're using a tablet, as you probably know, you can squeeze the tool so that it fits the best possible on your screen and take a screenshot of it, and that sends it to your photos, and you can later print that photo or text it or email it. So one of the reasons I like, even if they're, this is back to Randy's question, if there's no fan in the kitchen and I'm not going to put one there, I could just unclick this and kitchen goes away. No, I'm sorry, I've really confused things. There's a fan in the kitchen. It's already there. It's giving us at least 100 CFM, so I can choose to ignore it. Well, I might decide, well, the kitchen's already set. It's qualified, click it. The problem with that is now you don't have any record about the kitchen fan. If you click this, now when you take a screenshot of it and maybe put it in the file, put a printed record in the file, you can see that the kitchen has got a fan in it that qualifies for the minimum local ventilation requirement. And that's a positive thing, I think. You've got to document things.
Right.
So that is, any questions about using the tool or any of the red tools out in the field without a connection? It can really be frustrating if you get it wrong and you press this button or this button, because then you're stuck. There's nothing you can do but go to a Starbucks or something and hook up again, or if you can find a internet connection or something. Okay. Hearing no questions, I'm going to go to something else. People seldom ask this question because they don't know enough to ask this question. I really like to get this information out there. The ASHRAE standard is available free online. And I compliment ASHRAE for doing that. All of the significant standards are available free online. I really don't think you need to pay $62 or whatever it is to buy the standard. Sometimes, however, you do want to know what's in it. So I'm going to show you now. It's pretty quick. I'm going to show you how to find it online. If it were as simple as just a link, I would have sent that to Liz and Al to send out to all of you. But it's not that simple. And again, if you took notes on using the red tool out in the field without a connection, here's another note for you that you ought to take. You go to ASHRAE.org. So you can see the URL up here, ASHRAE.org. I'm going to hit enter. It's taking me to the website. Here's the ASHRAE.org website. That's step number 1, and now I'll give you step number 2. Step number 2 is there's a lot of interesting stuff here, by the way. Step number 2 is to go to this drop-down, Standards, Research, and Technology. And you can see it does drop down, and then you choose the first item, Standards and Guidelines. Takes you to that page, Standards and Guidelines, right here. All you do now, we're almost there, is you scroll down where it says Preview ASHRAE Standards. And right here you can see Standard 62.2, 2016. And by the way, 2013, if you go here, Preview Other ASHRAE Standards, you can find 62.2, 2013 there. But I'm going to go to 2016. I'm going to click there. And you cannot get here directly, as I've already said. Now I'm going to the standard, and here it is. You can see it's 52 pages up here, and the condition is that, first of all, you can't print this, nor can you save it. But you can search it. That's really helpful. There's a search up in the upper left, and the whole thing is here. I'm scrolling through it now. Everything's here. So you can read the standard, and here's section 4, very important section 4, dwelling unit ventilation. Notice I can't even copy text. So they've protected it, but you do have the option to read through all the nitty-gritty of the standard if you ever need to do that. Maybe you won't, but if you ever need to, there's really no reason to buy it. But if you do want to buy it, right up here in the upper right is a buy now. So that's how to read it online if you need to do that. So I'll get out of that now and back to the 62.2 tool. So that's it for my prepared remarks. Are there any remaining questions?
I don't see any on the chat boxes.
Okay, and I want to invite you to, probably best to filter questions through, if you have any questions, probably good to filter them through Al and Liz. They might be able to answer them. But I am very happy, whenever need be, to field questions from Al and Liz or any of you directly. You can get in touch with me or my business partner Charlie Holly through the red website. There is support right here. You can go to the support desk and ask us a question, or you can come to me directly. I'm happy to do that whenever you feel the need. If you go through Al and Liz, I think there's an advantage because they are also then getting an idea of potential issues that need more explanation that maybe they can take care of at a building technical committee meeting, or that they get a better sense of how you're doing with using this out in the field. Now, Liz, I think you said something about the Hancock tool that you wanted to go over.
Yes,
I should be quiet so you can do that.
Okay. I just have one more slide, but we want to thank you very much for all of your assistance, not just today, but ongoing. So
Yes.
we really appreciate it, Rick.
Absolutely.
You're welcome. Happy to do it.
Thank you. So I'm going to see if I can take back the screen.
I'll hit stop sharing. That should help.
Oh, very good. Thank you. You did that for me. I didn't even need Karen. Okay. Thanks, Rick. So the last thing that Al and I wanted to cover today for you, and thank you for attending today, is just some guidance about entering information into the Hancock tool. Hancock is a little further along now, and we have some better idea about what we would like to see in there for recording the information that you get when you're on your audit and your inspection. So as you see in the slide, for the audit, we would like to see the audit information for the existing bath fans only on the Hancock heat infiltration ventilation screen. So this is going to be the record of the audit conditions.
And kitchen, if there is one, not just bath fans.
Yeah, so anything, yeah, so the infiltration ventilation screen has a place to enter kitchen
Yeah, you said bath fans.
and bath fans. Oh, okay. Yeah, so any ASHRAE related item, which would be your kitchen or your bath. So that's going to be the record of what's there at the audit, and that won't be changed. So then you're going to use, and by the way, you can still use the ASHRAE Excel worksheet if it's just for a single family, single unit building. We will simply change the title of that to 2016 on August 1st, which is the day that all of this will go into effect. So you still will have that option. If you are doing a multifamily building, however, you will need to use the red tool. So your estimate, which you're going to use to build your job and figure out what you're going to need to install for ventilation, you can do that either on the worksheet or on the red calc tool. We're not going to require that you upload that to Hancock anymore. So we will be requiring the final ventilation result. And Rick pointed out how it's really important to put your final blower door number and your final measurements of the installed ventilation equipment in that tool. So you will use either the red calc tool or the Excel worksheet to put in your final ventilation results. So that will be uploaded to the Hancock WAP documents, along with your final ventilation inspection checklist document, which of course you will go over with the client. And obviously those two documents should align with each other. The numbers should match. So that was really, and we will answer more questions about this if you have any, and we plan to put a more succinct version of this slide onto the Hancock bulletin board so that you'll get used to seeing it and have a clear understanding of what the requirement is for documentation in Hancock. So we do want to say thank you very much for attending today, and we will be sending out a survey to find out how helpful this was for everyone and any improvements that we can make. So again, we appreciate having everyone on board today, and enjoy the rest of this beautiful afternoon. Thank you.